Suppose we have the following situation. We are given with 3 squares glued to the sides, each with an area of 2 square units. If we put a large square on top of it, such that one vertex is situated on this point, and the 2 sides passes through the 2 corners of the top smaller square, what is the common area between the 3 small squares and the large square? Here's how we solve it. Assume this angle is theta, this angle is alpha, and this angle is beta. It is an already known fact that squares have right angle or 90-degree corner angles, so this is 90 degrees, and also this one. Using angle addition, theta plus alpha is equal to 90 degrees. Let's write that down. Move the angle alpha to the other side to get theta equals 90 minus alpha. Similarly, beta plus alpha is equal to 90. Let's write that down. Transpose alpha to the right side, and we get beta is equal to 90 minus alpha. Note that the expressions for angles theta and beta are equivalent. We can now conclude that angle beta is equal to angle theta. Let's clear the board. Going back to the concept of squares, we must locate some right angles in our figure. This is a right angle, and this is also a right angle. Recall as well that the sides of a square are congruent, which means the following sides are congruent. Assume this is triangle 1 and this is triangle 2. Since both triangles have 2 identical angles, namely theta and right angle, and the side between those 2 angles are congruent, we can conclude that triangle 1 is congruent to triangle 2 by the angle side angle, or ASA congruence theorem. Congruent triangles means that the triangles have the same area. So instead of solving for the area of this region, we should try to find the area of this region. We should end up with the same area, but this time, this is much easier to solve as this is just the area of 2 squares combined. Each square has an area of 2 square units, so the area of the shaded region is just the combined area that is 4 square units.